These are the review Hi everyone. These are the review problems that we worked in class for our Unit 4 test, which is upcoming very soon. Okay, the first two problems deal with the population sample, sample statistic, and population parameter. Now, if you look back on here, of course, those are identified for you, and I put a star by them because we really need to know those. And you need to figure out in your own way how you are going to determine that. The way I do it is, whether the question asks for it or not, I always find out what is the goal of the study. The goal of the study, if you read this, is to test the effectiveness of garlic for lowering cholesterol in American adults. Now you can rewrite that if you want, or again, it may not ask you that in a question. But this is super important because this is where you are going to get your population and your population parameter. Those are going to come from your goal. This is from your goal, and this is the who, and this is the what. So, what do they want to know? The effectiveness. Of garlic in reducing cholesterol. And who do they want to know it about? The American adults. Okay. Now, how are we going to do that? Well, the sample is, how did they get that information? Well, in the sample, they treated 2,000 adults. And then the sample statistic here is the result. Cholesterol measures were measured before and after. The average change was a reduction of 3.2. So that is our result. 3.2 micrograms per deciliter reduction in cholesterol. And you don't even have to put the in cholesterol in there. These outside are from the goal, and inside is how they tried to find this result, and then the result. So these two go together, and then the goal tells you what they're going to apply to the larger population. Okay, the next one. The publishers of a magazine want to know the mean income of their subscribers. Okay. Well, that's what they want to know. The mean income of their subscribers. And that is our goal. From here we can tell our population, or the subscribers of the magazine. And they want to know the mean income of those subscribers. So again, these two go together from the goal. Alright, so now the how. What did they do? They sent an email to a random sample of 100 subscribers. And what did they find? The mean income is $91,250. And of course, I'm sorry you couldn't see any of that. So the goal is to find the mean income of the subscribers. So the subscribers was the population. The mean income is what they want to know. How did they do that? They sampled 100 subscribers. What did they get the result? 91,250 was the mean income of those subscribers. So that's probably going to be close to the mean income of all of their subscribers. Okay, all right. For each situation, state the sampling method used: simple, random, systematic, convenience, or stratified. Okay, so a pop culture magazine predicts the Oscar-winning Best Picture by polling readers who voluntarily respond to their email. That's just convenience. Okay. They're only going to use their readers. So this is definitely convenience. The City of Austin wants to know the effectiveness of its animal control policy. It conducts a poll of the residents whose address ends in 3. This is systematic. It's not random. They didn't just choose the ones close to City Hall, but they had a system. They wanted to pick every address that ended in a 3. To find group leaders in a classroom, the instructor put the names of all the students in a hat and randomly selected 5 names. This is simple random. And then finally, a cosmetics manufacturer wants to know the effectiveness of its skincare products. They divide their customers into men and women, then select a random sample from the group. They divide their customers into men and women. They must have thought the results would be different for men and women. So this means they stratified it. And then took a sample from each one. Same thing if they were, it could be men or women. They could maybe want to do blondes versus brunettes, or some other way that they think the results might be different. Okay, for each of the following, state if it is quantitative or qualitative. Now we know that quantitative or quantitative is numbers that can be counted or measured. And we know that qualitative is categories. Okay, and what do we mean by this? These are the responses to the question. The responses to the questions are: you going to get back a number, or are you going to get back a word? Okay, so a survey of students wants to know the average number of hours of sleep they get. The average number of hours of sleep. This is going to make it quantitative. It is a quantity. A restaurant wants to know the customer's favorite item on the main menu. This would be qualitative. And a qualitative, why? Because their favorite item on the menu would be lasagna, or I have no idea, ramen noodles, who knows, steak, whatever it is. So it would come back as categories. I'll go back and do the graphs in just a second. Okay, a movie studio wants to know the public's favorite type of movie. That is going to be qualitative. What would the answers be to that? The answers would be action, science fiction, romance, superheroes, whatever it is, their favorite type of movie. A movie studio wants to know how many movies the public attends each month. So how many movies, the answer is going to be a number. I go to 6, she goes to 7, he goes to 0. So this is going to be quantitative. Okay. Now let's go back and talk. Once we know whether it's qualitative or quantitative, we know the kind of graph that goes with it. Okay. So for a quantitative, we would use a histogram. Oops, I'm sorry. Or a line graph. And for qualitative, we're going to do a pie chart or bar graph. Okay. All right, so let's see here. The Department of Mathematics at ACC is interested in the average time it takes students to complete their math homework. They asked tutors to hand out a log of the time they spent on the homework to students who visited them in the tutoring center. Students returned the completed log to the tutoring center after 4 weeks. The collected surveys revealed that the homework completion time was 7.5 hours a week. Okay, so is this an observational study or an experiment? This is an observational study. They didn't tell the students how many hours to study each week. They just observed and recorded students' study habits. We didn't try to change them. Now let's think about bias and think of it as selection or participation bias. I can actually find both. Okay. Let's see. They asked tutors to hand out a log for students who visited the tutoring center. So that to me is selection bias. Only students who attended tutorials. All right, then students return the completed logs after 4 weeks. I would say that is participation. Only students willing to keep a log. And that probably skewed the results a little bit. I'm going to move this down because I keep... Okay. All right, suppose the math department randomly selected 100 students from 8 different courses and asked them to keep a log. Describe the differences in the study and the possible differences in the results. Okay. All right, well, it was still observational. But I think the bias is removed because they just random selection, and it was after stratified. So I think some of the bias was removed. Now still, so I would say the selection bias may have been. Participation bias. It still relied on students willing to complete the survey. But I actually think the results might be more accurate. Because if you take, you know, you're probably, the kids who go to tutorials are probably the students who are spending more time. Okay, 10 years ago, according to government records, 27% of Americans had dental insurance. This year, a poll revealed that 30% of Americans have dental insurance with a margin of error of 3.5%. Okay, so we've got a couple of things going on here. We have a statistic, and we have a margin of error. We use those two items to come up with a confidence interval. So if I do this, in my confidence interval, my statistic is going to go right here in the middle, which in this situation is 30%. To that, I'm going to add my margin of error, so that's 30 plus 3.5, which is 33.5. This is going to be 30 minus 3.5, which is 26.5. This is my confidence interval. Okay. So the confidence interval is, you can write it two ways. It's 30 plus or minus 3.5%, or you can write it as 26.5% to 33.5%. So based on their sample, they came up with this statistic. Had they chosen another sample, it probably would have come close, but probably not have been exactly 30%. Had they been able to poll everybody in the country, it probably would have been close to 30%, but not exactly. But what they feel confident enough in the way they chose the sample, the way the study was conducted, that if they polled another group or if they polled the entire population, the statistic would be somewhere in between 26.5 and 33.5%. Okay. Can you conclude that the number of Americans with dental insurance has increased from 10 years ago? Okay, well, let's see here. 10 years ago, it was 27%. So 10 years ago, it was 27%. Today, it is 26.5% to 33.5%. So can you determine that it has increased? Well, I would say no. For it to be certain, the confidence interval, let's say all the confidence interval, should be above 27%. But now I put a note in here. It is likely, but not certain. Okay. All right, let's talk about just a little bit about bias again. There is much debate about the proposed voter registration laws. Write 2 examples of survey questions about the issue. One that would be biased towards people who favor the new laws, and one that would be biased towards people who are opposed to the new law. Okay, well, we talked about how to write questions and what the possibilities of what they could mean, and by the wording. Okay, so one that would be biased towards people who favor the new laws. Okay, so it would be a question that would mean it is favorable for the new law. So I would write something like, do you think the new voting laws will result in more accurate elections? Okay, or even something like, don't you think the new voting laws will result in more accurate elections? Because that's what the whole goal of it be. One that would be opposed, so people opposed for the new laws. Okay, well, what are the things that are people who are in opposition to it? Do you think the new voting laws will make it more difficult for some groups to vote? Okay. Alrighty. Yeah, I think we've got time on this video to go ahead and do this one. Let's see here. What are we going to do? Table shows exam scores of a class of 30 students. So we want to complete the frequency table. Okay, so what does that mean? I need, the bins go from 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99. Okay, and we want to find out how many scores are within that. Well, let's see our total first of all. So our total is 6, 2, 3, 4, 5 by 6. So there are 30. So when I add all these up, it should equal 30. So that's a good place for me to start, where I need to go with that. Okay, so let's look at the 50 to 59. There's 1, 2, 3. Okay, let's look at the 60 to 69. Okay, there aren't any in there. Okay, let's look at the 70 to 79. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's look at 80 to 89. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And finally, let's look at 90 to 99. So 1, 2, 3, 4, 5, 6, 6. Okay. So 13, 24, 30. Okay, so they add up to 30. Now, I didn't put it on here, but of course there are other pieces of this as well. You need to find the relative frequency, which is just, this is a percent, so this would be 3 out of 30, 0 out of 30, 10 out of 30, 11 out of 30, 6 out of 30. As well as you want the cumulative frequency, which means you just add them up. So 3 plus 0 is 3, 13, 24, 30, and it should equal that. Okay, so on the grid, we want to create a histogram and a line graph. We need to create a title. Okay, I'm going to be real creative here. This is going to be exam scores. And these are going to be the scores. And this, of course, is the frequency. Now, and I know this is going to be a histogram because this is quantitative data. and I'm going to put it into bins. Okay, so I need to go from 50 to 100. So let's just say 50, 60, 70, 80, 90, 100. And my highest bin is going to be 11. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'll come back. Okay. All right, so for my 50 to 59, there are 3 of those, so I'll have that filled in right here. From 60 to 69, there are 0. From 70 to 79, and remember the right-hand rule here, there are going to be 10. So this is going to go up to 10. Okay. Then my next one here is 80 to 89, and there are 11 of those, so it's going to go all the way to the top. And then from 90 to 99, there are 6 of those, so it's going to look like right here. Okay. So now you've got your histogram. It's not colored in very well, but that's okay. All right, so now there are a couple other things that we could do with this if you wanted to. You could talk about symmetry, you could talk about skewedness, you could talk about a lot of different things. So, you know, if I were to ask, there were questions about that, you could see that this was skewed left, because you've got a couple that are outliers here. Most of the data is between 70 and 100. Okay. Let's see. The following scatter plot describe the trend or no trend. Now, what I would do first of all is I would draw a line of best fit. I would draw my trend line. Remember, the trend line goes through the data. It does not need to touch any of the data points. It just needs to reflect roughly the same number above and below. Now I can see this has a positive correlation. It goes up from left to right. And if I were to draw a little corral around this, I call it a pickle. I think that looks more like a pickle than the eclair in the donut. I love that, but that's just not what I've done. They're pretty close, so I would consider it a strong. Okay, so let's see. Let's describe the relationship as one variable causing the other, coincidence, or some underlying cause. Well, selling sunglasses does not directly affect the number of ice cream cones sold. The number of ice cream cones sold does not directly affect the number of sunglasses sold. So one variable does not cause the other. I do think it's more than a coincidence, because I think there is a common underlying cause. There is a strong positive correlation between sales of sunglasses and ice cream cones, probably due to increased sales of both, and
the summer, the warmer months.
So you can describe why you think the correlation is the way it is. Okay, I'm going to switch videos here.